Hi, today we're going to carry on factorising quadratics where a is not equal to 1. To start with, try these two questions here, which is a recap of what we did previously. So, to factorise this, we need a 5x here and an x here. That's the only possibility. And then remember, it's two numbers that multiply to give minus 6, but they don't add to give 13. We've got to think about how the 5x comes into it. So, I'm going to go with 2 and 3. As a starting point, some factors of 6. You could do 3 and 2, or 1 and 6, 6 or 1. 5x times 3, I'm going to write over here, 15x, 2 times x, 2x. And I can see if I make this, I need one of them to be minus. So if I make this minus, then I'm done. I can get the minus 6, and I can get the positive 13. So I happen to just stumble across it on the first go. Sometimes it takes longer, but there we go. This second one, didn't talk about this last lesson. There's a little trick you can do. You might have maybe tried to do it with minus x's inside the bracket, but a really good shout is to actually factorize out the minus completely. And you just switch the signs then inside the bracket because I've basically factorized out minus 1. And now I just have to factorize this one here, which is exactly the same as the one below. So I get nearly the same factorization, but just switch this, put a minus in front. You could have written it, you could have put the minus back in and had minus 5x plus 2, x plus 3. Perhaps you got it that way by using similar methods to last lesson, or 5x minus 2 minus x plus 3. These are all valid answers actually, because they're exactly the same. It's just, do I take the minus out of the whole thing, or do I multiply one of the brackets by minus 1 or the other bracket by minus 1? It goes then. Today we're going to look at slightly different quadratics to factorize where a is not equal to 1. And here's the first example. Now actually, you may have seen this before, or you may not have, but it's a very special type of quadratic. It's called a difference of two squares. If you ever have a quadratic with the x squared term, and then you're minusing a constant, actually you can do it really quickly because a squared minus b squared is equal to a plus b, a minus b for any a and b. You can see when you multiply it out, you get a squared, you get minus ab, but then you get plus ab, and then a minus b squared. So they cancel out. So there's no x term. You can, of course, you could turn it into what we did last lesson, right? 4x squared plus 0x minus 9, and then do the same method as before. You'd have to realize to do that. But the best thing to do is write it in this form a squared minus b squared. So it's going to be 2x squared minus 3 squared, 2x all squared. That's the same thing as 4x squared. If I multiply this out, it'll be 2x times 2x, it'll give me 4x squared, and then 9 is 3 squared, and then I'm sorted. I can literally just write down that it's going to be 2x plus 3, 2x minus 3. So these are really quick once you get your head around them. Try this one here. First step, write it as 5x all squared minus 1 squared. Okay, this is a special case where we've just got a number here. And then it's going to be 5x plus 1, 5x minus 1. Don't forget, in the past, you should have looked at things like x squared minus 9, and that just becomes x plus 3, x minus 3. This is just an extension of that. Here are some questions to try. Similar, and then they get slightly more difficult as you go on, but use the same kind of processes that we've been covering. Here are the answers. So 1 to 6 are very, very similar to the examples. When we get to number 7, you've got to actually realize you're factorizing with two variables, but you can still treat it as a difference of two squares, and so on for 8 and 9. Number 10, actually this is a bit more awkward because it's not in the form a squared plus minus b squared in the same sort of way. So the trick is to, always a good idea when you're factorizing actually, take out the common factor first. It becomes 5x squared minus 9, and then you can do a difference of 2 squares. The same goes for number 9 as well. Number 10 actually works as well, so you just got to treat that a is x squared plus 4 and b is x squared minus 2, and then you'll get x squared plus 4 plus x squared minus 2, and then in brackets, I'm going to run out of room, but it's going to be, let me put the bracket down here, x squared plus 4 minus x squared plus 2. It's a double negative going on, and actually so these are being multiplied together. If you follow through and simplify, you will find that you get this answer here. Of course, you could do it by just expanding the double bracket and expanding the double bracket, but that will take more time, and it's good to have knowledge of this, even though it's a more challenging one. And then for the later ones, you can write them all as a and b, and then it will just work out really nicely when you factorize it. So you obviously can do it by hand, but this is just 51 plus 49 times 51 minus 49, which is 100 times 2, which is 200. So there's little tricks to all of these. It's really nice to see that you can do calculations quickly using this method. Right, here goes. We're now going to look at the sort of the hardest questions that we might be asked to factorize. And the reason this is harder is that now there's a number in front of the x squared that is not only not equal to 1, but it also has more than 2 factors. So if it was 2x squared, it has to be 2x and x. If it's 3x squared, 3x and x. But now they're not prime, they could have many combinations. And we've got to try and figure out what to do. And actually, the method that I'm going to give you is just essentially a trial and error method. You just try them out, just like you did for these numbers here. It will work. Yes, I admit it can be a little bit time consuming, but practice makes perfect, and it's a the method from before still works. So here goes. Here's an example. Okay, let's say that we put in 10x and x like we did before. That's a starting point. And then we'd be trying out some numbers. So it would be maybe 3 and 2. That could be one possibility. And then again, so for these ones, if you're becoming more confident, you might even try and kind of do them in your head. Now we know we're adding all of them. I think I'll take it slow actually. So I'm going to get 20x and I'm going to get 3x. There's no way that could work. If I switch it around, I'm going to get 30x. Like I can immediately see that's not going to work. So already that one's out. If I put in 6 and 1, or 1 and 6, that's going to be massive. I'm going to get 60x, and 6 and 1, I'm going to get 10x, but I'm going to get an even number. So I can rule out the 10x basically. Just realised I need a bit more space. So we sort of ruled out that it could be 10x by looking through all the factors. Of course, if this number had a lot of factors, this could be time consuming. Let's try 5x and 2x then. So now it's going to be a similar kind of process. I'm going to try the 3 and the 2. I get 10x and I get 6x. That's not going to work. Remember, actually, I need an odd number there, so that is worth bearing in mind. Maybe if I switch it around. Now I get 15x and I get 4x, and suddenly we're there. All right, it took 6 attempts in this particular case, but I got there. It's going to be 5x plus 2, 2x plus 3. The method works. Try this one yourself. So let's go for it. First of all, I'm going to try 8x and x. Now the nice thing about this one is that there's only one possibility for the number. It's going to be either 5 and 1 or 1 and 5. So here I'm going to get 8x. Here I'm going to get 5x. There's no way that's going to work. Let's switch it around to 1 and 5. I'm going to get 40x and 1x. There's no way that's going to work either. So I'm just going to rule that out very quickly. So I think I've ruled out that it could be 8x and x. So let's try 4x and 2x. Again, 5 and 1. That's going to give me 4x and 10x. Nope, sorry. What about 1 and 5? Now I get 20x and I get 2x. So this looks like it's going to work because actually I've just spotted this is negative and this is positive, so they're going to both be negative for this to work. I need a minus 20x and a minus 2x. I need a minus 5 and a minus 1. That will still multiply to give me 5, and then it will add together correctly. So my final answer is 4x minus 1, 2x minus 5. Yes, there's some patience, but it didn't take that long, and the more you do, the easier it will become. Here's some more to try. They get increasingly more difficult, but it's the same process. This will test your patience, but you'll get really good at finding the factors and using this method. If you finish, can you construct your own quadratics to challenge others? Can you make the numbers even bigger? Go for it. Right, here are the answers. So there's some of them it's just 8x and x. Some of them you get this sort of combination. So I hope that the method makes sense. I hope that you're happy with it and you can now factorize basically any quadratic that can be factorized. Just take your time with it, use a solid set of lots of working, and you can get there. Brilliant effort.